All right, well, welcome to another Coffee with Bruce. I'm here today with Aleksandar Kuzmanovic, who's a computer science professor from Northwestern University in Chicago, somebody I've known for years and years, and is also the chief architect and founder of a really interesting company called Bloxroot Labs. We're going to talk about them in a minute. Now, Aleksandar, we've known each other for a long time. Going back to one of your early publications, I think I was the shepherd who had to sort of help you get the paper ready for publication. I can't remember, how long ago was that?
That's been quite some time. I think it was 2005 or so.
2005. So
Yeah.
my recollection is that this paper was actually really amazing, that you were doing this crazy kind of off the wall stuff and you haven't stopped in 15 years. You're just always finding kind of avenues to pursue that nobody else has gone down. And so this, this paper got published at SIGCOMM, which, probably the hardest networking conference to get a paper into. And you've sort of never looked back from there.
Bruce, thank you so much for such great words. So that's great to hear. Yes, I mean, you were a shepherd for the paper. I assume you also reviewed that paper before.
Yeah, that's right. I did review it. I was like, we want to publish this paper. We just probably need to make sure that it gets a little bit cleaned up for publication.
And typically those that don't like the paper, they get assigned the shepherd.
Okay, well, so today we're mostly going to talk about things related to blockchain. And, I did an intro to blockchain video just a few weeks ago. And so today we're going to talk about some of the technical challenges that you've been working on around blockchain. And so I guess, people know varying degrees that blockchain has some performance issues, that, the rate at which you can do transactions on most of the big public blockchains is pretty poor. And I guess what most people don't really understand is like what causes those performance issues, and even more to the point, like what can we do to address them? So that's kind of the topic I want to tackle with you today. So maybe you could just start off by explaining like what are the key performance challenges in today's public blockchains?
So basically, I just have to again re-explain myself. In the context of blockchains, blockchains are kind of invented, designed by cryptographers. We can say so. I and my former student Uri, we are networking folks like yourself, right? And then we started looking at this problem. We figured out like, hey, this is a computer networks problem in the sense that you have all these different nodes that have to communicate to each other. The more efficient they talk to each other to communicate, the faster they send data and do things at the endpoints, the better off the blockchain is going to be, and it can actually scale thanks to the networking layer. And so this is how we started looking at the networking approaches to helping blockchains get to a better state.
Right. So effectively, it's that the guys who designed blockchains, who were without doubt very smart people, kind of didn't think about the networking challenges. So maybe you can sort of start talking us through what have you done to isolate those networking issues, and how are you tackling them?
Yes. So basically, computer networks, we know for a long time about peer-to-peer networks. I mean, there's been a lot of research in our community about that, and we know that I mean, they do have their own issues and problems, which is endpoints they have to connect to all these other nodes, then send data to each other and so on. In the networking community, we've been working for decades, I would say, on trying to make things better. And this is where things like content distribution network came to be. This is why we now have YouTube. And so you can just click on your smartphone or on your laptop and the video is coming and millions of people are fetching terabytes of data. And in such an environment, looking at blockchains, what was interesting to us, because there you have pretty small blocks that are being exchanged among these different miners fairly infrequently. And the natural question to ask was like, hey, can we do this any better? And how can we build an infrastructure to help this happen?
Yes, it's almost like the people who designed the blockchain protocols kind of didn't believe that networks worked very well, right? So they designed them on the assumption that the network couldn't transmit large amounts of data very quickly. Whereas in fact, like we all know that over the years, thanks to things like content distribution networks and other kinds of overlays, that it's actually become possible to do amazing things distributing, say Netflix content, gets streamed out at, probably terabits per second or whatever. And
Yes,
so
yes.
there actually are good proof points for how to distribute lots of information quickly. It's just that it hasn't been leveraged by the existing blockchains.
That is all correct. And on top of that, there are some specifics in blockchains that make them even more prone to making them better, right? And so, I mean, without diving into too much details, basically there is this a double data distribution problem, kind of where, as you explained last time, people are sending transactions to the miners, and then miners put those in blocks, order them, and then exchange among each other, right? So in this process, what happens is that data is transmitted effectively twice. Once when they come from users to the miners, and the second time from the miners to among each other, right? And so this is an obvious case for network level content caching, right? And this, to an extent, is one of the things that Bloxroute is doing, basically building an infrastructure that caches all these transactions throughout the network infrastructure such that when the blocks are sent, they can be significantly compressed, much more than any other data in any other field. And this is one of the things that we use to make things more efficient.
Right. And my understanding is that today the sort of the size of block is a pretty important parameter in the way blockchains operate, and it's somewhat an artifact of the way people were thinking when they designed these protocols, that they picked blocks that were very small so that they could be confident that the same information are propagated to everybody in some reasonable amount of time. But that small block size has proven to be a pretty big impediment to performance.
Yes, so basically there are two important parameters. One is the block size itself, and the second one is interblock times, right? How often are these blocks generated? And so initially, when people designed blockchains, there was this like, hey, let's be careful not to screw this up. Which is why they used a pretty small block size and they spaced them pretty widely, because there was a fear like, hey, what happens if nodes are not synchronized and so on. And so this was done fairly conservatively, and basically what has been shown lately is that basically there is a huge performance gain that can be achieved by deploying this network infrastructure and also adjusting these parameters.
Right. And what's holding back people from just say, let's just move to really big blocks today?
So, I mean, I've spent some time in the blockchain community, and so there is a lot of, how can I say that, very deep philosophical divide on those who fundamentally don't believe that this should be done. So, for example, Bitcoin Core is one such community and blockchain where they believe that on-chain scaling isn't a problem that should be solved, and that basically Bitcoin itself is just the value that can be then exchanged in other ways, right? And there are others who believe, other projects that do believe that scaling on-chain is important. And so there are many different ways that people are doing what we are doing at Bloxroute. We are telling them, listen, sometimes we can help you a lot, sometimes not as much, but in any case, having a strong network infrastructure below is going to be good for you in any case. So we are happy to help.
So I feel like I got very clearly that one of the things you can do is you can reduce the total amount of information that's being sent using caching, which is kind of like the same idea as content distribution networks. It's just you're applying that idea to blockchains. Are there any other kind of key innovations that you see happening to improve the performance?
Yes. So basically, one thing that we're doing is block streaming. Basically, as we know, like routers on the internet are store and forward type of devices, where you first store something and then forward. And all the nodes in blockchain are also kind of store and forward type of devices, because because nodes have to first inspect whether a block or a transaction looks good and only then sends. And so this is hurting a lot with the performance. What we are doing, we are basically doing this thing called cut-through routing, which is a very well-known thing in switches, has been there for like 30 years, which is that once you start receiving a piece of data, once you figure out where you want to move it, you immediately start sending bits of data to the rest of the world, okay? And so basically this is what our core nodes are doing. And given that blocks can be, in our world, can be of much bigger, this is helping stream the data so that they can actually reach the destinations. And we do the checking only at the edges, so we are not complicating the core of our network.
All right, so I'm gonna try and play back what I think are the key points here. You can give me a score out of 10. So the first thing is that like the state of the art with existing blockchains has tended to be send small blocks, don't send them very often. That way you can be sure that everybody gets everything and everybody's kind of in sync, but the price you pay is really terrible performance. And that, it's really obvious, like blockchain, the Bitcoin blockchain does a few transactions per second, right? Which is never going to be, causing people at Visa to be worrying about using Bitcoin to do credit card processing. Yeah. So that's kind of the problem statement in a nutshell. And then now that you've got that as the problem, there is a couple of techniques to solve it. So first of all, you just want to enable people to send a lot more transactions, which ultimately means they've got to send more information either in bigger blocks or more frequently or both. Mm-hmm. And to make that sort of work, you've got a couple of techniques. One is to cache information so that you don't send the same information twice. You can do things like you just send an index that says, oh, here's the piece of information you saw previously. This is the very short key that tells you you've seen it before. And then the second thing you can do is to say, if you do get a big block, you don't have to hang on to the whole thing before you do something with it. You can actually start processing the front of it and start passing that on to your neighbors while receiving the back end of the block. So there's kind of no penalty to having a bigger block, which means I can send larger amounts of information around.
Mm-hmm. That is all correct. And just to add like one other thing, which is not really something that is unique to blockchains, but it's a networking problem, which is like, because we really have to push data all over the world, and the quality of internet is not the same all over the world, and yet there are many miners in China and places like that, and hence trying to make sure that things work well in such areas is we are doing some common things that they're not unique to blockchains, but still are necessary in order to run the network smoothly so that we can address these issues.
And with that sort of things, like just trying to find, among all the different paths you could send yes. a block, you try to pick the one with the best performance, which is the sort of thing we've seen in overlay networks and yes. software-defined WAN and so on.
Yes, yeah. Exactly.
Fantastic. Well, look, I think that's actually probably a good amount of information to cover off today. I think we've got a good understanding of like where the challenges are in performance, why we should try to fix them, and some of the techniques that are being developed to solve them. And we'll come back another time and maybe go a little bit deeper into some of the next steps.
Thank you so much. Yeah.
Perfect.